Okay, hello everyone. First off and first most, I need to give credit where credit is due. You should always do this. And these fine gentlemen are well, this all this writing over here is from Dr. Sanchez. So all credit goes to them, especially Dr. Sanchez. We're going over here, and then we'll remake this equation using the continuity equation because I did make a mistake a long time ago. I'll show you what mistake I made a long time ago. And then we will also explain how to get this equation, and then we'll go to this equation, and finally we'll go to this, and then this one hopefully if we have time, and these two if we have time, and this last one if we have time. Okay, so that's the plan. We're gonna start over here. As you know, all my recordings are sped up by 1.5 because I talk slow. I noticed that about myself. I talk really slow, so I tend to make sure that you guys can listen, somewhat decently by speeding everything up. Anyways, with that said, I'm gonna stop following myself and stop following my tablet because my tablet is easier to deal with for now. Anyways, so we start off with the energy equation this time. We already did the momentum and the continuity, but we do need continuity again. I'll explain why. But we start with our beautiful equation over here. dE, oh, I should probably do the big one, but I don't know, we'll go small. We'll do every single step again. Plus grade, you see, this is why you need to always redo it because you make small mistakes if you're not used to it. And you see, I already made like two mistakes. You need to keep on doing it, in my opinion. It helps you. V, and remember, all of this is a scalar, so we have to make sure that we are in total doing a scalar work. If we're not doing scalar work, then you see here, I almost did a gradient, and that would have been wrong. And then we do plus, and then we have to do tau, double bar, dotted with gradient to V. Now here, if I didn't do a double dot, it's not a scalar. Watch out for if it's not a scalar, then you're doing it wrong. Understood? Understood? Yeah, you understand. Okay, so make sure you're doing it. And yeah, that's it. I was about to say something interesting, but there's no need. I mean, we already talked about most of it. Over here, we now know that we have to use our dH equal dE plus D parentheses. I believe it was, oh, we should probably write the whole thing out. Anyway, so what am I about to do again? Oh, you can also do it from pressure and volume. Yeah. Definitely another way to get things done. There's multiple ways to get things done. Just take it one way, and you're good. And then dH minus dP over density plus, no, minus, uh, okay, minus, once again, P D puts the 1 over density. What this allows us to do is go over here and run it over here. And notice that big D is the same thing as saying DE, I believe. How I know that? A long time ago, someone told me this, and I'm going to take it as fact for now. I hope I'm not wrong. Yes, I think I'm right. So density equals, I believe, uh, dH dt minus 1 over density dP over dt minus d, well, it doesn't matter, but it's going to be density squared by d t o d rho dt to be plus 9. Am I correct about this? I hope I am. But a little bit more confusing here. And then we have a plus p dot gradient v. And also, because of Euler equations, these two goes to nothing. We already discussed this before. We have the middle terms. No, I could do that, which I believe it was d density over dt is equal to, I believe, is plus gradient dot v equals 0 or something like that. Another way to write it. See here. And this form looks suspiciously a lot like this form over here. And this will save our asses. I moved to somewhere else because I had to. Anyways, let me do this again. So as you can see over here, another form of this thing is this equals density v dot v equals 0. And that is another form. That's another form. So as you can see, that's another form. This equals d and dt. This is another form, which tells you that you can get d density dt equal to negative density v dot v. And this, along with what we had over here, we can put it into here, and we should get something. Next, you see over here, you have this and that. These two cancels to rho dh. I had to move spaces, by the way. As you can see, the background is different. This that gives you what you had. Okay, we have reformed the equations to get the right versions. Um, okay, we did that. Anyways, what does that help me with? Equals 0 because the other side 0 goes away and so forth. Not impossible to do. After that, you get the final version. That will give you this form. This thing is then given to you because if you integrate that, that implies that the S equal SO is the same. So therefore, you can integrate the other equation, the state, what was it called again? The equation state, that's what's called. Next, we can do what we call TdS equals CV dP over P, and then it was plus C pi d rho over rho or something like that. I think I did this right. It's pressure and then rho, right? Uh, because it's CP over CV. Yes, that is right. I think, yeah. And then you finally get this equation. Now, how do you get this to this form is the next question. Let me do that real quick, which is a little bit tricky, and I'm pretty sure it belongs to Taylor series. Always Taylor series. Good old P over P I equal P over P I. No. Rho over rho I alpha. Uh, and then we can just do a little bit of manufacturing, which is P equal, I believe, P prime plus PI or something like that. So this will go into, I believe, is PI plus P prime, and then with PI over here, which equals to, then well, it will be P rho I plus rho prime divided by rho I, parentheses alpha. That's 1 plus P prime over PI. That's the easy version. We have 1 plus rho over rho I divided by alpha. Okay, we have a conundrum here, and I believe this conundrum can be solved by Taylor series. Now let me look up this Taylor series because I don't remember. It's ln over here, and this is 1 plus P pi over Pi, which means this is ln of parentheses 1 plus alpha I over I like this. And then I need to look for the Taylor series, so let me search up the Taylor series for this stuff. What is the Taylor series of ln? Here, okay. So I don't remember the Taylor series for this, so let me search this up. It'll take a while. I don't remember it. Here, beautiful. Let me put this into here. All right, Taylor series over here. Oof, that's large, that's large, that's large, that's large. Okay, so we know what the Taylor series is going to be. The alpha should be outside like this. So we have our Taylor series, which shows over here. So it's this version over here that we want. So since this is a small perturbation, this is going to be small, this is going to be small. We can use this Taylor series, which is going to be Pi over Pi equal alpha, rho I over rho I, and this is going to be plus order of something. I don't really know, and I forget. But the important thing is this Taylor series tells you rho I, no. P pi equals Pi rho I alpha, which is a square, and then it's rho pi. So the variation of those two, we see that now is Pi over AI dx plus du is kept, I think, and then ux, and then I think he changed it to, oh, this is a square, right? It's a square, check. Yes, AI square.